So why are there 360 degrees in a circle? Who decided that? What's the reason for it? And it reminds me kind of the discussion of the dinosaurs. All right, why are dinosaurs extinct? Okay, and there's a couple very good theories, right? One of the theories is a meteor hit the earth around the Texas area, I think, or Mexico area. Another theory is the ice age, right? Both are very plausible theories. Nobody really knows for sure. I actually do know somebody who truly believes that dinosaurs are extinct because they were too big to get on Noah's Ark. So when the Great Flood happened with Noah's Ark, the dinosaurs couldn't get on, and that's why they're extinct. So I know someone who truly 100% believes that. But anyway, I'm getting off on a tangent. So why are there 360 degrees in a circle? So there's a couple different theories, and it might be some combination of both of these. You know, there's plausibility to both of these theories. The main two theories then, one has to do with the fact that 360 is a highly composite number, which means it breaks up so nicely and easily. It's got so many different factors. So that's really convenient because, again, you might not recognize this if you haven't done a lot with math, but if you've done stuff in trigonometry where we deal with dividing up our circle into, you know, different sections, it really is nice that we can divide our circle into 8 sections or 6 sections or 10 sections and so on. There's also, part of this also goes back to the theory about the Babylonians who used a base 60 number system. And we did take a look at that Babylonian number system that was base 60. What's kind of interesting is I made this handout for this particular year, but then I was going through my files of other courses and other years, and I actually found this description that I had taken one year, and it's talked about, you know, here's a reference source for it in a book, Reading the Numbers. So it talks here about, again, this idea of the base 60 number system. Again, 60 is a very easy number to work with too. It also has a lot of different factors, and you know, we've got the base 60 number system that's part of history that might be a factor in this. But another theory has to do with astronomy and the length of a year. And it shouldn't surprise anyone that in ancient times, when they were first studying astronomy, they thought that the Earth was at the center, right? That the Earth didn't move, but the sun and the moon moved. Okay. And it's that makes perfect sense because we're all kind of egocentric that way. We all think we're the center of the universe. Okay. And so then I think it was very surprising when some astronomers started saying, like, no, the Earth rotates around the Earth rotates around the sun, and then the moon is rotating around the Earth. Okay. So that was a very unusual idea, you know, kind of considered a sort of out there scientific idea when that first came about. But anyways, these astronomers would watch the sky and they would notice that the sun's path moved about, you know, they broke it up into like 360 degree chunks, right? For that circular path of the sun, it took about 360 days for it to completely move back around. And therefore they defined the degree based on that the amount of time that the sun moved, the angle that the sun moved each day, they called that 1 degree. All right. And so therefore it took about 360 days to get back to normal. And some of the ancient calendars did have 360 days on them. And so down here it talks about really the same idea, and I'll post this handout if you want to read it more carefully, but this one kind of combines theory 1 and theory 2. So again, this was something that I had taken and copied and pasted for a different class, but I'm actually going to share another video with you where someone goes through this. They have a cool accent, and so their cool accent makes them sound smarter and more interesting than me. But anyway, while we're on the topic of angles and degrees, I have an exercise for you to complete. So one of the things that you're going to do for participation is you are going to determine the length of each angle shown on this handout. So there are 9 different angles, and you're going to use the dots in the picture to help you. Okay, so what those dots have done, like we could look at this one here in the middle. Okay, what those dots have done is taken the circle, right? Like if I were to draw a circle around here, taken the circle, but divided it up into, so for this one, 1, 2, 3, 4, 5, 6, right? 6 chunks. Okay, so it divided the circle up into 6 sections. So what that would tell me then is between any pair of points, right? So between this pair of points and this pair of points, if I have just divided the circle up into 6 sections, right, like this, and there's 360 degrees about that central angle, each of these is 60, right? So then the measured angle accounts for like 2 pieces of this pie. So in this case, the measured angle would have to be 120. Notice if I wanted to do some work with regular polygons, I could actually use this handout because what I normally would do if all of you were in class and I could hand out protractors is we actually measure off angles to create regular polygons, and then we play around with those regular polygons a little bit. So I just created here an octagon, right, by using this the central angle, right, this circular path, but if I connect each pair of dots with straight lines, I get a regular octagon. So the use of angles like this is used if we want to draw our regular polygons and get a nice perfect drawing for those. So anyway, I'm going to let you complete this for classwork, and you can move on and watch a little bit more about why there are 360 degrees in an angle, or in a circle, not in an angle, in a circle.